Let's take a closer look at positive and negative autocovariance and autocorrelation. We see up here the formula as if we have multiple realizations. For the autocovariance, we have gamma hat of xt1, xt2 equals 1 over m minus 1, where m is the number of realizations, times the sum of I equals to the number of realizations. This cross product, where for each realization we have xt1 at time t1 minus the mean at t1, the estimated mean at t1, times xt2 at that particular realization minus the estimated mean at t2. And so from that, again, we can get this positive autocovariance, a measure of how xt1 and xt2 move together, be it positively or negatively. So let's look first at an example to kind of shed some light on this. Beautiful. So we've got, let's say we've got 4 points. 1, 2, 3, 4. There we go. So we have those 4 points. And let's say we've got 3 realizations. So in these realizations, I'm going to say we go from, let's say this is realization 1 in green, and it goes high. And let's say that it just kind of wanders around up here. Just say it does something like that. Great. And let's say that the yellow one, we'll call this realization 2. Pretty close to that, and it just kind of wanders around kind of similarly. And then the blue one here is observation 3. Let's say it started off a little bit lower, but kind of had the same behavior. It just didn't move too far from where it was the time before. Let's say that it did something like that. Something like that. Okay, great. So what does that tell us? So first what we're going to do, we're going to have to find x bar t1 and x bar t2 and x bar t3, and we'll have to find the x bar for each of these time points, whatever t1 and t2 might be. They're general right now. So what we'll do here is say, okay, well, at this one's got 2 highs, so I'm going to put a pink dot here, which we'll call the pink dot. I'm going to say is the sample mean at that particular point in time, a different population this process is generating for each slice of time. So at the second one, they all look pretty similar, right? They're going to be a little bit different. Those are all a little bit higher, so I'll push that one a little bit higher. And those are all a little bit lower, so I'll push that one a little lower. But that pink dot is the respective mean for each time slice. And so what we're going to do to look at this is talk about how far apart we are in time, t2 minus t1. And we'll also talk about, we'll label on here, the sign of this, talk about positive and negative autocorrelation. And then I'm also going to, it's going to be the same sign, but underline the fact that we have rho xt1, xt2, rho hat, which is just gamma hat xt1, xt2, which is just this value, divided by sigma hat xt1, sigma hat xt2, where those are, of course, both positive. Variance is always positive, so the standard deviation is always positive. So if this happens to be negative, then the autocorrelation, that's the autocorrelation, will be negative. If this happens to be positive, then the autocorrelation will be positive. So those signs will be the same, but just to underline that those two quantities exist. This one is standardized between 1 and -1, like the normal correlation, linear correlation coefficient. This one is unbounded from negative infinity to infinity, and this is how far apart we are in time. So I'm going to say, hey, let's think about if we were 1 unit apart in time. And so I'm going to estimate that using 1 and 2. 1 and 2 are 1 apart in time. So let's check it out. Let's just kind of run through the positive and negatives of this. When m is 1, or sorry, when I is 1, m is going to be 3 overall, but when I is 1, we'll be talking about the green one, and the green one was above the mean in time 1 and above the mean in time 2. So running that through our equation here, this will be 1 over 3 minus 1, so this will be 1 over 2 because there's 3 realizations. So 1 over 2 times the sum, and the first cross product in that sum, there'll be 3 of these. But the first one relates to the green one, and that will be this green dot is this point, and that green dot is that point. that pink dot is that, and that pink dot is that mean. And the green is always above its corresponding mean, meaning that's positive, so that'll be a positive number. And that first be three numbers, a number plus a number plus a number. The first number is positive. Let's look at the second one. That is a little bit a smaller number, but it's still positive. So that would be this minus this is this minus this. That's bigger, so that'll be a positive difference. That's bigger, that'll be a positive difference. So the second number will also be a positive times a positive, which would be a positive. So far we'll have 1 over 2 times the sum of a positive number plus a positive number. And we go down here to the blue one. The blue one is below its corresponding mean. So this minus this will be negative. But this blue one is also below its corresponding mean. So this minus this will be negative. And so a negative times a negative will be a positive. And so the autocorrelation here, or sorry, the autocovariance, but the autocorrelation also, excuse me, in a minute, will be 1 over 2 times a positive number times the sum of a positive number plus a positive number plus a positive number, which of course will have to be positive. So that autocovariance will be positive, and since the standard deviations are always positive, the autocorrelation, they'll always share the same sign, but of course that'll be positive as well. Okay, so let's talk about at lag 2. What does that even mean, right? T2 minus T1. So we've got to look at that right here. These are 2 time points that are 2 apart. We could look at 2 and 4. That's about the only 2 we could look at, but let's just look at 1. Let's let T1 be 1, and let's let T2 be 3. Those are 2 units apart. And we can see on here we have the same kind of relationship we did at lag 1, right? Just looking at these two, at this slice of time and this slice of time, let's go realization by realization. So for 1 is above the mean, and realization 1 is above the mean in time slice 3. So that's going to be 1 over 2 times the sum, and then this minus this, that's a positive number, this over this, right? Now that xt2, T2 is 3 now. So that would be, this number is that, and that pink number is this, so that'll be a positive number, positive times a positive. And let's go down, green above it, green in time slice 3 above it, positive, positive, blue below it, blue below it. So that'll be, this number would be this one, when when I is 3, this number would be that, and this number is always that. So that's going to be a small minus a big, it's a negative, and this is small minus big, which is a negative. And so that'll be a negative times a negative, which is a positive. So this would be 1 over 2, again, times the sum of a positive number plus a positive number plus a positive number, and that would be positive and positive. Shall we do one more? Why not? Just to see that this behavior, and we can go, so there's only one, with our data here, with only 4 slices at a time, we only have, these are the only ones that are 3 units apart. So we've got to look at those, but we see it's the same idea. Above the mean, that'll be a positive cross product. Above the mean, that'll be a positive cross product. Below the mean, when these are 4 apart, it was still below the mean. So that was negative, negative is a positive. So this again will be 1 over 2 times the sum of a positive plus a positive plus a positive, which will mean both of those are positive. So this is a good look at positive autocorrelation and positive autocovariance. So let's now look at maybe a different idea. We can call that time, since we have some space here. So this is 1, 2, 3, 4, 4, 3, 2, 1, and let's play the same game. So we've got xt here. Should have labeled that as xt. And let's say this time we have a dot, and again I'll call that realization 1, and it goes down, and then it goes back up, and then it goes back down. Okay, and let's say, hey, we can afford another realization. We're able to get it. So let's call that realization 2, and it starts right here, and goes down here, goes up here, and then it comes down there. And then you've got realization 3, which actually starts way down here. And this one says, oh, that goes up, and that goes down, and that goes up. And there we have it. So that is realization 1, 2, and 3, but it just looks to us like different behavior. But let's see what the calculation of the autocovariance has to say. Again, we'll do T2 minus T1 at lags 1. And we'll have the autocovariance at xt1, xt2, and we'll have rho hat xt1, xt2. Okay, so we'll check that out. So we'll just, again, we could take 1 and 2. We could let T1 be 1 and T2 be 2. We could let T1 be 2 and T2 be 3. We could let T1 be 3 and T3 be 4. But let's just, for simplicity here, look at 1 and 2. So we got to put our means on there. Again, I'll say that is the mean, and this will be a little bit lower. That one will be a little bit higher, as there's 2 points, and then that one will be kind of probably right about in there. Okay, recalling again, we'll just label it for clarity that pink dot is the X bar for that corresponding slice in time point. All right. So let's see what happened here. So this is still 1 over 2. This is 3 realizations, so 3 minus 1. 1 over 2 times the sum, I equals 1 to 3. The first realization, so xt1, if I'm talking about that point right there, minus its corresponding mean. It's above it. So that factor in the cross product would be positive. Now what about this one? By the time I get to 2, the green point has gone below the mean. So it started out above the mean, and now it's on the other side of the mean. So that's this number here is that number there. The x bar T2 is that guy right there. And so that's below it. And so that'll be a negative number. So that part of the cross product will be positive times a negative. So that would be a negative. So it's going to be 1 over 2 times the sum of 3 numbers. That first number is negative. So now let's go to realization 2 is above. So here, that'll be a 2 now. And so this will be... that's above. So this number would be positive. But by the time it gets to T2, which is 2, it's below the mean. It's below its corresponding pink dot, below its corresponding sample mean. So that will be a small number minus a bigger number, and that'll be negative. So that again will be positive and negative, and a positive times a negative is negative. So far I have 1 over 2 times the sum of a negative number plus a negative number. Great. So now let's go on to realization 3. So we let I equals 3. We come here. That blue dot is that one. That pink dot is still x bar T1. That's below. So that's negative. That's above. By the time it hits T2, that's above. So that's positive. A negative times a positive is a negative. So that'll be 1 over 2 times the sum of 3 negative numbers. And that, of course, will be negative. That is what we're looking at there is negative autocovariance, which will translate into a number relatively close to -1, or at least negative, between 0 and -1. So of course, if this is negative, these are always positive. So if this is negative, that'll be negative. Okay, so think about that for a minute, but that is, it looks different, and that's how we can kind of quantify that numerically with the autocovariance and autocorrelation. So now let's look at lag 2. What happens when we get time points that are 2 units apart? Does anything change? So I could look at 1 and 3. I could let T1 be 1 and T2 be 3, or I could let T1 be 2 and T2 be 4. But I'm just going to keep it simple and go 1 and 3 here. So let's see what happens at lag 2. So at lag 2 here, we'll have, it's above, right? So at T1 of 1, that's above. So this will still be 1 over 3. Or 1 over 3 minus 1. So 1 over 2 times the sum of this point, which is that one, minus that one, which is this one. We've established that. So that'll be a positive number. But now we're over here at 3. And what has happened? Since it went 1, it went to 2. But by it goes to 3, what's happened? Well, that point is back above the mean. So it started here. And by the time it hits 3, it's back above the mean again. So that's a positive difference. So that's positive times positive for I equals 1. Positive times positive, that'd be a positive number. Great. What about the green one? Well, we can see that there. That's above its corresponding mean. That's positive. By the time it gets to 3, that's positive. Positive times a positive is positive. Oh, how about the third time we got to see this process at work? We got realization 3. It was negative. By the time it got over to 3 again, it was still negative. It was below the mean, so that's a negative cross product, negative factor. And this one was below its corresponding mean, so that's negative. And negative times a negative is positive. So here we'll have 1 over 2 times the sum of a positive number plus a positive number plus a positive number. because it was positive times positive was a positive, positive times positive was a positive, and negative times negative was a positive. And so that gave us, at lag 2, a positive autocovariance and autocorrelation, which is interesting, right? It's kind of really highlighting what it means to be a little bit farther apart in time. And let's go for one more here and say, hey, what happens when we got 3 in time? The only thing we can look at here is 1 and 4. And we start to see kind of what this is called. We're going to call this oscillating behavior, and kind of what the autocovariant signature is of oscillating behavior. So this is saying, let's go one more time. So we go from 1 to 4. So the blue one, or the green one, this obviously is above its corresponding mean. So that'll be a positive product. So it'll be 1 over 2 times the sum of this positive factor. What about at 4? Because now we're letting T2 be time 4. So it was up above the mean. By the time it gets to 4, it's below the mean. So that'll be a positive times a negative. So that'll be a negative. Now, how about realization 2? That's positive, clearly, a little smaller number, but still positive. And by the time it gets over to 3, it's a little smaller number, but it's negative. So again, that'll be positive times a negative. That'll be a negative product. So far we have 1 over 2 plus the sum of a negative number plus a negative number. What about the third realization? It started below. So that is this number minus that number, which would be this, which would be negative. But by the time it gets over to 4, it'll be positive. And so that'll be a negative number, right? That's bigger than that. So that difference will be positive. Negative times a positive is negative. And so by the time it gets to lag 3, we're back to 1 over 2 times the sum of a negative number plus a negative number plus a negative number, which that whole thing will be negative, and thus the autocorrelation will be negative. So we can see here that in this particular sense where we have this positive autocorrelation, we've shown that even at lag 1, 2, and even at 3 apart, when they're looks like it's not getting too far away from where it started, this behavior would be positive autocorrelation all the way to lag 3. Whereas when you have something that's oscillating, what you can see is that at lag 1, when it's on one side of the mean, it ends up on the other side of the mean. That's indicative of negative autocovariance and autocorrelation. But if you go 2 units apart, if it goes somewhere and comes back, it's often on the same side of the mean, which would be positive correlation. But then you go at lag 3, and that's the oscillating behavior. The autocovariances are oscillating. So by the time you get to 3, wherever it started, it's usually on the other side of the mean. That's, again, negative autocovariance and autocorrelation. So great. Nice job. I'll see you in the next one. Good work. Sample autocovariance and sample autocorrelation when we have a special case of a process that's generating this series that's stationary. So we'll start with our autocovariance formula when we had multiple realizations, noting that's gamma hat xt1 xt2 equals 1 over m minus 1, where m is that number of realizations times the sum of that cross product. But now we don't have multiple realizations. We only have one. But we did say that we have a stationary process that's generating this time series. So we recall that that means that the mean does not depend on time. That the mean at x1 is the same as the mean of x3, is the same as mean x5 all the way to x8. And that the standard deviations, or the variances at 1 at time slice 2 of x5, of x6, x7, x8, that they're all the same. That they don't have t subscripts here. They're all assumed to be the same, and that they're finite. And then finally, that the autocovariance here does not depend on where we are in time. I can assume the autocovariance is the same here as it is up here. It only depends on how far apart we are in time, meaning that lag 1, if I'm only 1 unit apart in time, that might have a different autocovariance than at lag 2 or at lag 7. So that's what we'll look at here. And learn a lot about it in the process. So let's say we have this series, but it's from a stationary process. So if that's the case, let's go ahead and put a different formula up here. And because again, we only have, like if we tried to use this one, we only have one realization. And so right off the bat, that would be 1 over 1 minus 1, which would be 0 and to be undefined. Other things like each one, the mean would be the same if we were assuming that it wasn't stationary and we're trying to use these multiple realizations. So if we have stationarity, we will have gamma hat. Now, under condition 3, it doesn't matter where we are in time. So the autocovariance from 7 to 8 is assumed to be the same autocovariance if I'm at x1 or x2. So I can drop this xt1 and xt2 and just talk about how far apart we are in time. So I'm going to call this k we're going to use k to be the lag. And over here I'm going to put k equals t2 minus t1. And maybe we'll put that over here too. See that t2 minus t1? We'll remind ourselves that let's let k equal t2 minus t1 just for simplicity of notation. So k is what we're going to call the lag. So we'll call lag. So gamma k, we don't need those anymore, is equal to, it's going to be defined, we'll talk about this a little more later, of 1 over n, but times the sum of I equals 1 to n minus k. And that'll actually be really important. We'll talk about that as we go along too. But let's see if we can simplify some of the rest of this. We don't have any realization, so I don't need that, that qualifier up here. And I'm just going to say that this is xt, wherever I am, minus x bar, because I don't need the t1 anymore, right? It's just xt minus x bar. And so that'll be this first product, or this first factor. And then the second factor will just be the one that's far enough out in time. So that'll just be xt plus k, that's k units away from this one. And then at that time point, in the future, what does the future mean assumed to be? The same thing, right? That's the nice thing about stationarity, is I can borrow information from other slices of time because they're assumed to have the same parameter, in this case, the mean. So this mean and this mean are assumed to be the same, so I'll just write them as x bar. And I'm just looking at t and then k units in the future. How are those correlated, or what's the covariance of that? So this is the formula for the sample autocovariance. So let's check out, I'm going to put k up here, and we'll talk about various k's. I'm going to look at the sign here of gamma hat k. We'll talk about rho hat k, which is just right, gamma hat k divided by sigma hat. So that's sigma hat x t and sigma hat at the new one, off in the future, xt plus k. Don't want to get too far down the road in this, but note, for under condition 2, this standard deviation is assumed to be the same as this standard deviation, right? So I could really write this as rho k. Yeah, I could really write that as, I already wrote rho k. Really write this as, got to be efficient with our space here, gamma k divided by sigma squared, and we'll just call it xt. For any old, we'll just call it sigma x. We don't even need a t. Right? We don't need to qualify it where the time is. That's the same as that. So that will be, don't forget the squared, that will be the variance. So the standard deviation at this point in time times the standard deviation at that point in time, doesn't matter where we are in time, it's assumed to have the same standard deviation. So that'll just be the variance of x. Great. So we'll have that. So let's talk about what we have here at lag 1. That is the point. That's the main point of what we want to talk about here. So since we can again assume that the auto covariance is the same anywhere in time, we can start looking at these points, and we can assume that the mean is the same. My estimate of the mean is just the mean of all 8 of these points. And the mean of all 8 of these points looks to me to be about maybe right there. And I'm just going to call that x bar. So if I can assume the mean's the same, then I can use all the points to estimate that same mean. And so we have that. So what all I'm going to do here is to try to calculate this. I'm going to use this formula. Let's try it out. So I've got 8 points, so that'll be 1 over 8. And then at lag 1, when k is 1, I have these two are 1 apart, those two are 1 apart, those two are 1 apart. So that's 1, 2, 3, 4, 5, 6, 7. When I have 8 observations, there's only 7 pairs that are 1 apart. So that's why this is I equals 1 to n minus, in this case, k is 1. So 8 minus 1 is 7, because I only have 7 cross products I can look at. Cool. So when I look at that, here's the first one. So this is x, we could call this at t of 1. We'll start over here then. So we're going to talk about xt and xt plus k. So that's x1 and k is 1, so that's x2. So if I look at this pair, they're both below the mean, right? That's xt right here, and that's xt plus 1 right there. They're both below. This minus this is negative. This minus this is negative because that's x bar, and that's x bar, and that's x bar. So those will both give us negative, so that'll give us a positive product. So there'll be 7 numbers in this sum. The first one's positive. Let's look at the next pair. Oh, they're both under x bar, right? That's going to give me a negative product. That's going to give me a negative product. So that's going to give me a negative factor and a negative factor, and that's going to give me a positive product. Great. So anytime they're both under or they're both over, it's going to give me a positive product. So that's going to be, and that magnitude matters too. That's going to be a relatively large positive number. That's going to be a relatively large negative times negative is a positive number. How about this one? These are both still below. And so that's negative, 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 negative being positive, and that'll be a positive number. This one's pretty darn close to x bar. So this one will give us a positive, a negative factor. And this one will give us a negative factor and a really small number here. But still, that'll be a negative times a negative is a positive. And then we look at 5 and 6. So we look here. This point will be barely negative, and this point will be positive. So that number will give us a negative number, right? But so far we've had this pair. There's going to be 7 numbers in here. And the first number was positive. The second number was positive. The third number was positive. The fourth number was positive. The fifth number was a negative product. But now the sixth number, they're both above. So that'll be positive, positive. Give me a positive. And that's positive and positive. Will give me a positive. So there'll be 7 numbers in this sum at lag 1. 6 of them will be positive. 1 will be negative and pretty close to 0 because that point was pretty close to 0. And at the end of the day, at lag 1, we'll end up with a positive autocovariance because we'll take that positive sum, we'll divide it by 8, and we'll still have a positive number. And we know that the variance is always positive, the standard deviation is always positive. So if this is positive, then the autocorrelation will be positive. And now that we have that kind of framework down, let's talk about 2. Well, when k is 2, that's just saying x1 and x3, and x2 and x4, and x3 and x5, xt and xt plus k. So now I'm just looking at 2 units apart. Well, at 2 units apart, I've got 1, 2, 3, 4, 5, 6. I only have 6 pairs at 2 units apart. That's n minus 2, right? 8 is n, 8 minus 2 is 6. So I always have n minus k pairs to assess that lag, that autocovariance at that k. So here is 2. Those are both beneath the mean. That's going to give me a positive cross product here. Let's shift it over 1. There's 2. Those 2 are still below. Both are below the mean. So that's negative, negative. That's going to be a positive cross product. Let's shift it over here. Still both below. So now the first 3 numbers, that's negative, negative, they'll give me a positive cross product. The first 3 numbers are positive, positive, positive. That's here. Now I go here. This one's pretty significantly negative. And this one is pretty significantly positive. So that's going to give me a relatively medium-sized negative number, right? This will be some negative, whatever that distance is. I'm sorry, this will, at 2 units apart, 4 and 6. That'll give us this, and that'll give us that. So that'll be a sufficient or significant negative number there. But then I move it over to here, and that's a number that's pretty close at 5. That's a number pretty close to 0. That's negative 2. That's positive. So that'll give me another negative cross product. And then I'll go to 6 and 8, and that'll be a positive and a positive. So let's slow down because there was a lot of numbers going through here. There's 6 numbers in this product. And recall that at lag 2, that first one, that was negative, negative. So that was, the first one was negative times a negative is a positive. That was a pretty significant positive number. That's a pretty significant positive number because both are below the mean. This one was a smaller positive number, but still positive because that one's pretty close and it's going to get multiplied by that distance. But then this one here was a pretty significant negative number. So we had positive times positive plus positive plus positive plus a negative number because they're on either sides of the mean. Here, these are still on either sides of the mean. So positive, 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 negative, negative, and then this one was positive. That should add up to be less, a smaller number, but still positive. So we're saying this is positive, and this will be positive, but this would be a bigger number. This would be like plus 10, and this would be like plus 3, and this might be 0.9, and this might be 0.7 or something like that. So okay, so let's go out to 3. Why not? So at 3, we'd say, hey, here we go. Let's play again. So at 3, we know we have 8 minus 3, and we only have 5 looks at this. We only have 5 pairs. So there's one of them is this. Those are both below. So that's a in that sum there, it's going to be 1 divided by 8, but that'll be negative negative would be a positive. And I shift it over. Okay, now I've got this one that's pretty close to 0, but that's both negative, so that'll be a positive number. So a positive plus positive. Then I shift it over here. I've got a negative, right? That's below and that's above. So that's going to give me a negative cross product. That's going to give me a negative cross product, below, above. That's going to give me a negative cross product. At this point, maybe the negatives balance out the positives at lag 3, and I've got somewhere maybe kind of close to 0, which would make that close to 0. Maybe a little, it's going to be a little bit negative or a little bit positive, but relatively speaking, very weak, pretty close to 0. So that would be a look at when I've got a stationary time series with some behavior that kind of looks like this. Now, one more thing I want to add to this is this idea of a ACF, the autocorrelation function. In fact, I'm going to draw it down like that. I'm going to put 1 up here and negative 1 down there. Because if this is the autocorrelation function, the biggest it can be is 1, and the smallest it can be is negative 1. And so what we'd have here is this might be, like I said, that number right there might be 0.9. And in fact, what you'll see in software a lot of times is it'll start at lag 0, that's K. Well, everything's perfectly correlated with itself. So it's a little redundant, but it's pretty standard. At lags, it'll always plot lag 0, and so it'll start off here at 1. But then at lag 1, it'll plot whatever that number is. And I said, oh, well, maybe that's a 0.9. And then at lag 2, it'll plot whatever that is. And I said, oh, that one might be still positive, but less. So maybe that's a 0.6, 0.5, something like that. And then at 3, I said that was practically 0. So at 3, right, maybe it's just a little bit positive or something. And that's what we call dampening autocorrelations. But this number here is just that number there, and this number here is that number there, and this 0-ish number is that number there. So cool. So I'm going to do one more, right? Let's just do one now that we've got this framework built. I like to be complete and show kind of a contrast, 3, 4, 5, 6, 7, 8. But this time, let's say that we've got this realization that goes, again, a stationary time series. And in a stationary time series, this oscillating behavior might do something like that, right? It may not oscillate each time. So it would not be unusual for a stationary oscillation to do something like this. But 1, 2, 3, 4, 5, 6, 7, 8. Let's play our game again, right? If this was stationary time series, we'd say each of these time points has the same mean. So I just take the mean of all of those. I've got 1, 2, 3, 4, 5 high ones and 3 low ones. So maybe it's a little bit higher than that middle there, and we'd have X bar. Cool. And so then I'd say, hey, let's look at K, 1, 2, and 3. And let's look at gamma K, gamma hat K. And let's look at rho hat K. It's going to have the same sign, but for completeness. So if we did that, let's check it out, right? We've still got 8 points. That's 1 over 8. For lag 1, we're going to have 7 looks at this. We're going to have 7 sums, 7 cross products to add together. So here, at this point, and just remember, when they're on the opposite sides of the mean, that's going to be a negative cross product. And when they're on the same side of the mean, that's going to be a positive cross product. So that first sum, there's going to be 7 numbers in that sum. The first one will be negative because they're on opposite sides. The second one, they're on opposite sides. So that's a negative. Negative plus a negative, top, bottom, plus a negative, went from bottom to top, plus a positive, right? They're both above. So for this one, this would be a positive number, and that would be a positive number. But so far, it's been a bunch of negative numbers. Now I've got one positive number, back to a negative number, right, above and below, and then back to a negative number. So I have 7 numbers in that cross product. 6 of them will be negative, and 1 of them will be positive, so that their overall sum will be negative. And if it's negative, a negative number divided by 1 by 8 there, that'll be negative, and thus the autocorrelation will be negative. So now let's look at lag 2. So at lag 2, we'll see they're 2 units apart, and we've recalled that we've got 8 minus 2, so there'll be 6 pairs we have here. There's 1, 2, 3, 4, 5, 6. Let's look at 1 and 3. They're on the same side, so that'll be a positive cross product. 2 and 4, they're on the same side of the mean, so that'll be a negative negative because they're both below. Negative times a negative is a positive, so that'll be a positive number plus a positive number plus, those are on the same side, positive number plus, that is on opposite sides though, right? So 4 and 6, one's below and one's above because it skipped a beat. So that'll give us a negative number in that sum. So positive, 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 negative, and then this one here, right? Then I'm going from above to below again, so that'll be another negative number, and then end with a positive number. So in those 6, we'll have 4 positive numbers and 2 negative numbers. That will be more than likely a positive number, but smaller in magnitude than that negative number, right? And if that's positive, this is positive, but this could be, like if we're looking at autocorrelation, maybe this is negative 0.9 and this is positive 0.7 or something. And then we go back to 3. So in 3 units apart, we've kind of playing this game. That's going to give us 8 minus 3 is 5 pairs. There's 1, 2, 3, 4, sorry, 3. So 1, 2, 3, 4, 5. So 1 and 4 there are opposite sides, right? So that'll give us a negative number. 2 and 5, they are the same side. So that'll give us a positive number. So I got a negative and a positive. Here, right, got to pay really close attention. That'll give us a positive number because they're both on the same side. Here, that'll give us a positive number. They're on the same side. And here, that'll give us a negative number. So that's probably going to balance out to be pretty close, I'm going to guess, to 0. Right? We'll look at that more in depth in the future. But for our purposes, what we want to do here is just check that out. And if we looked at the ACF of this one, of this behavior, we would see, right, if this went from 1 to negative 1, it's autocorrelation function. At 0, it's always 1. So again, redundant, but you always see it there. And then here's 1. At lag 1, we'll have this negative number. So it'll go down low. Can't go past negative 1, but be pretty strong. We said this at 2, it'll be some positive number. And at 3, we said it's practically 0 at that point. Maybe it's just some, maybe we'll say it's a little negative. I think there were more negative numbers than positive numbers, but they pretty much balanced each other out. And so this is kind of a signature of an ACF that you'd see when you have this oscillating type behavior, is that you've got high, low, high, low. And then some, a lot of times it keeps going, depends on how quick it damps out. But that's a lot of information. But very, very important information when we're trying, and very elegant when we're trying to estimate the autocovariance and autocorrelation with only one realization. And if we can assume, or if we do assume that the process that's generating those realizations are stationary, then we can do a lot. We can do quite a bit and estimate quite a bit. So great job. I'll see you in the next one. So now let's use R to find the ACF. So jumping right in. We have got an example here called example 1. It's a series of 8 observations. I'll look at plots.wge example 1, and there it is. And it looks like it's wandering. Some might say increasing, some evidence of increasing trend. But what does the ACF look like of this? So just to kind of reference with the mean here to get an idea of that autocovariance and to have a reference point, I'll drop on here the horizontal line that represents the sample mean, by which the ACF would be calculated from, and there it is. So that's the sample mean. So we know at lag 1, we get in 8 observations. In lag 1, we have 7 looks at this. And so we've got from 1 to 2, and those are both below. So that would add a negative times a negative, because both of those are less than the mean. So that'd be a negative times a negative, a positive product to that sum. There'll be 7 sums. At lag 1, there'll be 8 minus 1, 7 sums added together. Those would be positive. 2 and 3 are both below, so that'd be a positive. 3 and 4, 4 is barely above, so it will be negative, but it'll be almost 0. It'll be a very small negative number. 4 and 5 are both positive, same thing though, very small number. 5 and 6, both positive, adding a positive. 6, 7, positive number. 7 and 8, very big positive number. So mostly we're adding positive numbers here. If we're not, we're adding very small negative numbers. So overall, the covariance here at lag 1 will be positive. And then check out for 2, right? From 1 to 3, we have 6 pairs that are 2 apart. So 1 to 3, both of those are below the mean. So that would be a that'd be a positive contribution to that cross product. Then we go from 2 to 4. From 2 to 4, again, that value is almost 0, so that's going to be negative, but it'll be very close to 0. 3 to 5, 3 is below and 5 is above. That'll be a significant negative number. 5 to 7 would be a positive, and 6 to 8 would be a positive. I imagine that'll be positive, but pretty close to 0. And then look, by the time you get to 3, right, now I'm looking at this point and this point. So I start off with a number close to 0. In this autocovariance cross product, I start off with, I'm going to have 5 numbers. The first one's going to be pretty close to 0. The second one's going to go from low to high. That'll be negative. This one will go from 3 to 6. That'll be negative. This one will go from here to here. That'll be positive, but almost 0 because of that point. And then this one will go from here to here, which will be a positive. So that'll be pretty clear and close to 0. So let's look at the ACF. So all I got to do is A equals ACF of example 1, and we can see it. So we said at lag 0, that'll always be 1. But then at lag 1, we said, yeah, it looks pretty significantly positive. At lag 2, some of those negative cross products brought it down a little bit. By 3, right, they almost completely balanced each other out. But now what are up with these negative ones, right? A lot of times like, well, I didn't really see that, but we didn't go out that far. So let's just look at this one at 7, right? And this is kind of an interesting idea. At 7, you only have one observation at 7. So it's really easy to see why it'd be negative. Because at lag 7, the only points that are 7 apart are observation 1 and observation 8. That's the only pair that are 7 apart. So that's a above and a very big above, and that's a below and a very big below. So that's going to give me one cross product, which will be a negative number, which is why at lag 7, that's a negative. And then at 6, right? Oh, that was even more negative. How did that happen? Right? You can just play these games all the time. But at 6, it's 1 and 7. So that's a negative and a positive, right? That's a below and above, so that's a negative. And then that's super below, and that would be super above, right? So that's a very big negative factor, a very big positive factor, which is why when you put those two together, that's where you get the biggest negative correlation. So I encourage you, go out, play with different series, make sure it makes sense intuitively, do this kind of counting game. But let's look at one more. I also have plots.wge example 2 that I've made previously, and if you look at that, that's got a very different behavior than example 1, right? Example 1 was kind of just wandering, looked like it had some evidence of increasing trend. This one is oscillating. And so again, if you play that game at lag 1, we've got 7 pairs at lag 1, right? If I was to put the AB line H equals the mean, if I assume this is a stationary time series, which I am, then I'll have that. There's the mean. So they're at lag 1, they're on opposite sides. From 2 to 3, opposite sides. From 3 to 4, lag 1, opposite sides. 4 to 5, opposite sides. It's a negative plus a negative plus a negative plus a negative cross product. All of these, if you follow them across, all 7 are on the opposite sides of the mean. That's going to be 7 negative numbers added together in that cross product, calculating the autocovariance. And so that'll be significantly negative autocorrelation. Now what about at lag 2? So from 1 to 3 and 2 to 4. Well, 1 to 3, they're both on the same side. From 2 to 4, they're both on the same side. Doesn't matter they're below, because that's going to give you a negative difference, and a negative difference will give us a positive product. So if you run that across here, these are all going to be, it's going to be 6 positive numbers in the autocovariance, because 8 minus 2, we're at lag 2 here, 8 minus 2 is 6, but they'll all be positive. So that'll go, at lag 1 will be a negative autocorrelation. At lag 2, it'll be a positive autocorrelation. So, and then at lag 3, from 1 to 4, look, notice at 1 and 4, it'll be above and below. And 2 to 5, below and above. And follow that across, all 5 of those would be negative. So, if I wanted to look at that, I will calculate the ACF now of example 2. Just like that. And no surprise, right? Again, perfect correlation at 1. But we start off with negative correlation, then positive, then negative, then positive, and it slowly damps down. Awesome. So that's how you can find it. I didn't show you this on the first one, so I encourage you to go back and look at A here. But at A2, the reason why I assigned it to a variable, in fact, you don't have the data there, so it'll be tough to do that. So I'll just, at A, those are the actual values that you see. So if we kind of go back here to this one, that value there, we said at lag 0, it's always going to be a 1. But at 1, that's 0.514. At 2, that's 0.199. At 3, like we said, it's almost 0, negative 0.018. And then you can see those negative numbers. And at A2, right, there's those. So if we come over here to the other one that we looked at, that is 0, that's negative 0.856, right? There's negative 0.856, 0.681, and then that's negative, positive, negative, positive, negative, all the way down. Awesome. So that's how you find the ACF in R and how you can also recover those autocorrelations in R. And in fact, I can't resist, if you wanted to find the autocovariances, right, if you do $, then you should be able to go to, let's show that, yep. So if you were to do, you have to tell it in advance to do type equals cove, I think. If we do that, then notice that this is not bounded by -1 and 1 anymore. It's the actual covariances. So if I look at A2, then now these just aren't standardized. So remember, the autocorrelation is just the autocovariance divided by, in a stationary time series, divided by the variance of x. And so that puts it on a scale from -1 to 1 for the correlation, but unbounded with the autocovariance. And that's how you can recover those numbers. So great job. Keep up the good work. Have a lot of fun. I'll see you in the next one.